Welcome back to our comprehensive course on Surds. In our previous lecture, we explored the fundamental concept of Surds, including their definitions and some of the laws of Surds. Today, we will delve deeper into the walls of Surds and uncover more advanced techniques for simplifying and manipulating these mathematical expressions. So in today, Surds Lecture 2, we shall be looking at simplifications of sorts. Now, let's get into the lecture. To simplify sorts. Now, when you look at the word simplify simply means to reduce a term into the lowest form. So to simplify sorts, meaning to reduce it to the lowest form, what we need to do is to first express the number under the square root sign as a product of two factors. To simplify sorts where possible, remember, it is possible for sorts to be in a simplified form. So when the sorts are not in a simplified form, we need to simplify it. So how do we do that? The first thing to do is to express the number under the square root sign as a product of two factors, one of which must be a perfect square, and then we will simplify by taking the square root of that perfect square. Please, this is where the concept lies. I want you to understand this clearly. To simplify sorts, we need to first express the number under the square root sign as a product of two factors. Then one of the factor must be a perfect square. Then we now proceed to simplify that perfect square. Now, what I'm trying to say in essence is, if you are given a sort, let's say square root of 45, and you are asked to simplify this sort, what you are going to do is, you are to break the number under the square root sign, this 45, into two factors. Then one of the factor at least must be a perfect square. Now, what's a perfect square? A perfect square is a number such that when you square root it, it will give you a whole number. As simple as that. A perfect square is a number such that when you take the square root of it, the result will be what? A whole number. For instance, we say that 4 is a perfect square. Why? Because the square root of 4 is equals to what? 2. It's a whole number. 16 is a perfect square. Why? Because the square root of 16 is what? 4. 9 is a perfect square. Because the square root of 9 is what? 3. So you see, whenever you are simplifying sorts, you need to first express the number under the square root sign as a product of two factors, one of which must be a perfect square, and then you proceed to simplify by taking the square root of that perfect square. From this illustration, I said, if I'm to simplify square root of 45, I'm going to split this 45 into two numbers. So I'll look for two numbers that when I multiply will give me 45. Then at least one of them should be a perfect square. So the number here is what? 9 times 5. Because 9 times 5 is what? 45. And you can see that 9 is what? A perfect square. So I can proceed to just break this as square root of 9 and then square root of 5. Then proceed from there. Okay, if you understand this concept, now let's look at some classical examples. We have the following example. Example 1. Simplify the following. Number 1, square root of 45. Number 2, square root of 32. Number 3, square root of xy raised to the power of 2. Then number 4, 2 root 50. So we have to simplify this. That means we have to reduce this to the lowest form. Now, let's look at the solution. Square root of 45. This is equal to, remember, we are going to split this 45 into two numbers such that at least one of the number must be a perfect square. Now, if you look at what are the factors of 45, of course, 9 times 5 gives us 45, right? And then 9 here is what? A perfect square, because the rule says at least one of the number must be a perfect square. So this will give me square root of 9 times 5. Now remember our rule for sorts. Okay, so we're trying to split the square root of 45. So we say this is 9 times 5. Now from our rules of sorts, remember we're told that square root of m times n is the same thing as square root of m times square root of n. So when we apply this here, we're going to have this to be equal to square root of 9 times square root of 5. Then the square root of 9 is what? 3, because it's a perfect square, times square root of 5 is a sort, so we leave it there. So this will now give us 3 root 5. That means square root of 45 is equals to what? 3 root 5. Now, number 2, square root of 32. To simplify this, we look for two numbers such that when we multiply the two numbers, we will get 32. That's the factors of 32. Then at least one of the number must be what? A perfect square. Now, square root of 32 equals to, now I can say 16 times 2. Of course, to get this number, you must always do trial and error until you get the perfect square. So 16 times 2 is 32, and I know that 16 is what? A perfect square. So applying this rule of sort, that square root of m times n is equals to square root of m times square root of n. So I'm going to now have this to be equal to square root of 16 times square root of 2. 16 is a perfect square, so square root of 16 is what? 4, times, we'll have here now square root of 2. So this will now give me 4 root 2. And that's the answer. It therefore means that square root of 32 is equals to 4 root 2. Okay. Number 3. Square root of x y square. How do we do this? Of course, if you break this, the two numbers that when you multiply you get, that is just x times y square. And of course you can see that y square here is a perfect square. So if I split this, I'll be having square root of x times square root of y square. And this is equals to square root of x is square root of x times square root of y square. Remember, this is the inverse of this, so this and this can cancel out, so you have square root of y square as what? Y. And this will now give me y root x. Therefore means that square root of xy square, when simplified, we will have y root x, and that's the answer. Now, number 4, we are asked to simplify 2 root 50. So to do this, we say this is equal to, of course the 2 is already outside, so I can just keep it outside. I have 2, then I split this 50 here. That's the number under the square root sign. So I look for two numbers such that when I multiply, we'll get 50. Then at least one of the number must be a perfect square. So when I split this 50, I'll use 25 times 2. I hope you understand what I'm doing. So this will give me 2. Of course, I can just break this into square root of 25 times square root of 2. And this will be equals to 2. Of course, with the bracket, it means times. Square root of 25 is what? 5. times square root of what? 2. So this is 2 times 5 is 10 times root 2. And 10 times root 2 gives us what? 10 root 2. It implies that 2 root 50 is equals to what? 10 root 2 is the simplified form. I hope you understand what we have done so far. Okay, let's look at another classical example. The question here says, express the following as the square root of a single number. Express the following as a square root of a single number. Now, remember, in our previous lecture, we told you that there's a rule of sort that square root of that a root m is equal to, when you push this one back into the square root sign, it will become a square times m. This rule is very important. So that means to express this simplified sort back to its original form, to a single number under a square root sign, we are going to be applying this rule here. Please take note. So now let's delve into the solution to this problem. Number 1, 2 root 3. This is equal to, applying this rule, we are going to have square root of 2 square, because I push these 2 back in here to have 2 square, then times 3. So this is equals to 2 square is what? 4 times 3. And when I simplify this, 4 times 3 is what? Square root of 12, and that's the answer. So the single root of this is now this. Now, it means that I can also solve from here back here. That's what I did in the first example. Now, let's look at this other one. Number 2, 3 root 10. So if I want to get a single number here under the square root sign, I say this is equal to, I push this 3 here to have, when I push it in, it becomes 3 square times 10. And this is equals to square root of 3 square is what? 9. And then times 10. So this gives me 9 times 10 is what? 90. And that's all. I hope you understand what I'm doing here. Now, number 3. 5 root 7. Now, this is equal to, if I push this 5 in here, I have 5 square times 7. So this will now give me square root of 5 square is what? 25. And this times 7. So now, what is 25 times 7? 25 times 7 will give me 175. And that's all. So now, the next one here, number 4. 2 cube root of 7. Now, please, I want you to take note of this. Remember the rule that a cube root of m equals to cube root of, when you push this a in here, because it was a cube root, it becomes a cube times m. For a square root of m, when you push this a here, it becomes square root of a square times m. You know, in square root, we don't need to write 2 because already a square root. So please take note of this concept. So 2 cube root of 7 is equal to, when I push this 2 in here, I have cube root of 2 raised to the power of 3 times 7, because we are dealing with cube root. And this will give me cube root of 8 times 7. This equals to cube root of, what is 8 times 7? 8 times 7 is 56. It therefore means that 2 cube root of 7 is equals to cube root of 56. I hope you understand what we have done so far. Okay, we've come to the end of this particular lecture. Let's give you something to play with. The first question here is simplify the following. Number 1, square root of 20. Number 2, square root of 84. Number 3, square root of 150. Number 4, square root of 288. B, express each of the following as a square root of a single number. Number 1, square root of, that's 2 root 11. Number 2, 3 root 8. Number 3, 5 root 7. And then number 4 root 6. I hope you understand what to do. If you have any challenge, kindly go over the lecture again. See you in our next lecture. In our next lecture, we shall be considering Surds lecture 3. Here, we shall be looking at operations with Surds. Thank you.